Hey, what's up, guys? This is Chung here. So today, number 576, out of boundary path. Okay, so there's like m by n to the grid with a ball, and the ball is initially at the position start the column and start row and start column. You're allowed to move the ball in 4 directions, right? And then you can only move at most this max moves, right? And you need to count the number of paths, basically the number of ways that you can move the ball out of the grid boundaries, and then do a modular by this big number. Right? For example, we have this 2x2 grid, and the ball starts at 0, 0, right? And then the total move we can make is 2. And for this one, we have 6 different paths, right? That the ball can move out of the boundaries, right? So 1, 2, 3, 4, 5, 6 within max move equals to 2, right? You don't have to use all the moves, but you cannot use more than this max move. That's why we have 6, right? And then here's another example, right? We have a ball like this, right? And the answer is 12, basically, right? And here are some constraints, right? 50, 50. Okay. So, I mean, for this kind of counting problem, right? So 99% of time, 99% of time is it's either like a math problem or a DP problem, right? I think during an interview, I think it's gonna be more like a DP problem, right? Because at this one, for this one, if we have like a grid here, right? So what does a DP problem mean, right? Basically, obviously, there are like many paths, right, that can lead to the same location. For example, this is the start, right? Let's say this is the end, right? So there are like many paths we can end up with this location place. You can uh, go here, right? Or even go here, right? There are a lot of ways that you can end up to this place. And if we just brute force all the path, that will be too much. That's why we can use a DP with some states to uniquely identify a current status, right? So obviously we have what? We have I and J. That's part of the two status we need, right? And the next one is what? It's the moves, right? So which means given like the current state and the number of moves we have here, for example, if this one, right? So here we have 1, 2, 3, 4. So and here 1, 1. Basically, this two paths, this two paths will lead to the same state because the I and J are the same, and the moves are the remaining moves should also be the same, right? So what this DP means, it means that if I'm standing at I and J and I have this many of moves left, okay, and then the total number of paths from this state to move out of the boundaries is fixed, right? So this means that as you guys can see, so the first time if we follow this path, right, and we reach here, right, and then we have like a state here. Sorry, there's a state here, and then we calculate that, right? We calculate that, and then we move it here. We moved out somewhere, right? After moving out, we know, okay, given this state, we have, let's say we have 10 paths, right, starting from here that can move out of the boundaries, right? And then the next time, right, when the s starting from here, when this s follow a different path, right, and reach this state, the state that has 3 status, then we know, okay, We already know, okay, we have already calculated this state before. So that's why we don't have to recalculate it, right? So obviously, right, that's why we can use this kind of three-dimensional state, right, to uniquely identify state. Because again, given the coordinate and the remaining moves, the number of paths to move, the number of paths to move out of the boundaries is fixed. Okay, that's why we can use DP to solve this problem. Okay, and for this problem, I think a top-down DP is more intuitive. Okay, yeah, and then let's start coding then. So the coding is pretty straightforward actually. So since we're doing the top-down DP, we have I and J, and now I have moves, right? This is the remaining moves basically, and now I just use this IRU cache to help me do the memorizations, so that I don't have to write it my own. Right. So the base case, obviously, the base case is whenever the coordinates is out of the boundary, then we stop. Okay. Or j is smaller than 0, or I is either greater than m, or j is either equal greater than n, right? So if it's out of boundary, then we return 1, because return 1 means that, okay, we have find a path, okay, that can lead us to out of the boundary. Okay. And we have some like invalid case, right? Basically, if the moves is equal to 0, right, then we return 0. It means that if the moves is 0, then we're still inside the grid. Then it means, okay, so this is not a valid path, right? That's why we need to return 0. Otherwise, answer is equal to 0, and then okay, we have directions. Okay, this two. Okay, and for direction in directions, so new I equals to I plus D0, right? So this is kind of a template. So I J plus D1, right? So now we don't want to check the boundaries, right? Because our purpose for this problem is to move out of the boundaries. So we should never check that boundary. We simply do a DP of new I, new J, and then move -1, right? And then we return the answer. So that's how we accumulate the answer into 4 directions. I will never. This one can lead to this out of boundaries. It will return 1, right? That's how we accumulate that. So that's it, right? So and then we have a modular here, +7, okay, and then just do a DP of start row, right? We start from here, start column, and the max move, right? Do a modular in the end. And that's it. Yeah. So it passed, and yeah. So the time complexity is what is the number of state multiplied by the time spent for each DP here. So the state we have what? We have they are like all 50, right? So it's gonna be a 50 cube, right? So because here is like 4, right? That's why 50 cube, and there you go, right? So I mean, a very classic DP problem, right? You just need to define like find like state that can identify the current status, right? In this case, it's the coordinate plus the remaining moves, right? And then some base case, and then the top-down DP. Cool. Yeah, I guess that's it for this one. Thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.